Okay, today we are in the week 5, so check-in 2. So today we are going to learn about expansion, factorization of algebraic formula. Okay, so this is the first questions that we have. Review exercise 4, page 115, number 2D. Okay, so we are going to expand and simplify the following expression. So I hope you still remember how to expand and simplify. Yeah? So how to expand, you just need to multiply 2w with the w. We have 2w square and then 2w times with minus 5x, so you get minus 10wx. Okay, yeah? And then after that you multiply 3x with w, so you get plus 3wx, and then 3x multiply by minus 5x, so you get minus 15x squared. Okay, yeah? So that's for the first part. And the second part, you have minus here and then bracket. Yeah, so you write also minus and then bracket. So it just play safe. Yeah, you don't have to multiply the minus first, you just leave the minus outside the bracket. Yeah, and then you do the same thing as the first part. So 3w times w, so you got 3w square, and then 3w times minus 7x, so you get minus 21wx, and then you multiply 7x with w, so you get plus 7wx, and then 7x minus times minus 7x, so you get minus 49x squared. Okay, close bracket. And now we try to join the like terms. Yeah, so we have like term, this is like terms, wx, and this one also like terms. Yeah, we can join this become minus 7wx, and these parts become minus 14. Yeah, minus 14wx. Okay, so we can rewrite here, so 2w square minus 7wx, and then minus 15x squared. Okay, now it's time for us to open the bracket. It means you multiply all the terms inside the bracket with minus 1, so you get minus 3w square, and then become plus this one, yeah, 14 plus 14wx, and then this one minus 49x squared become plus 49x squared. Okay, now we're done. And then now again we try to find the like terms. This one, yeah, red with red, so wx with wx here, and then I have green, so 2w square with minus 3w square, and then this one minus 15x square with 49x square. Okay, now it's time to join the like terms. So w square, 2w square minus 3w square minus w square, yeah, this is equal, yeah. Okay, and next is the wx, so minus wx plus 14 minus 7wx plus 14wx, so we got plus 7wx, and then the last one minus 15x squared plus 49x squared, so we have plus 34x squared. So this is the simplest expression that we can get. Okay, now for the second question, it's about a review exercise 4, page 115, number 3a. Okay, so number 3a, we are going to factorize the expression. So to factorize this expression, I hope you still remember about cross method. Okay, cross method. Yeah, so what does it mean cross method? So maybe you forget. Yeah, okay, no problem. So I want to remind you again. here we have x squared plus 2xy minus 63y square. So you look at the x squared here, you try to find the combinations of multiplications, two things that you can get, so that you will have the product of x squared. So in here, in this case, you get x times x, right? You will get x squared. Okay, and for the last term here, minus 63y squared, you also you have a sum of the combinations of the multiplication, so that you can get 63y squared. So in the first combinations, for example, you get minus y times 63y. You get 63y minus 63y squared, right? So the second combination may be minus 3y and then with 21y. This is also another possible values. And then the last one, I think this one, minus 7y and then times 9y, right? So this is the this is three possible value, three possible pairs of value that could have the product of minus 63y squared. But you also, it's possible also when you switch the minus can be in 63y instead of in the y, right? So you have more combination here. So I will try to use this one, yeah, minus 7y times 9y. So this is the cross method. So you write x and x here, okay, and then you write the 7y minus 7y and then 9y here. Okay, so this is for the x squared, yeah, last time, and then this is for the minus 63y squared. Okay, so after that you try to cross multiply here. So you get, here you cross multiply, you get minus 7xy, and then if you cross multiply here, you get 9xy, and then if you plus both of them, so you will get 2xy, and then you check this 2xy must be equal with the middle value here. So since this is the same, yeah, 2xy, so this is the answer, yeah, this is the answer, x minus 7y and then x plus 9y. So the answer here, the factor of these expressions is x minus 7y times x plus 9y. Okay, so this is cross method. I hope you remember. Okay, now this is the third questions. Review exercise 4, page 115, number 3C. So the question is asking you to factorize the expression, yeah? So these factorizations require the cross method that we did for the previous questions. Okay, so we have 6x squared y squared minus 5xy minus 4. So we are going to find the combination of 6x squared y squared. So the first combinations may be xy and then 6xy, right? So if you multiply it together, you get 6xy x squared y squared, and the second one is 2xy 3xy, isn't it? Or the other way around, the same thing. Okay, I think that's enough. Now we comes to the last number now, minus 4 here. The combinations could be minus 1 and 4. If you multiply, you get minus 4, right? And the second combination could be minus 2 and 2, right? It's possible. So, or maybe you get minus 4 and 1. Okay, so you have a sum of the option here, but I want to try this part, yeah. Okay, I want to try this pair and also that pair, yeah. Okay, so let's see here. Okay, so 2xy, let's use cross method, yeah. and then this is 3xy. So what do you think, which is which one? So the 4 minus 4 is on the top or on the bottom? I think I will choose minus 4 on the bottom here, minus 4, so that we will get minus 8, and then this one 1, yeah. So that it's because our goal is to make the cross method produce minus 5xy. So I think, yeah, I think it will works like this. So let's say this is the representative of 6x squared y squared, yeah, this one, yeah. And then for this one, minus 4 1, so this is the minus 4. Let's see here, when we do the cross multiply, so 3xy, this is 3xy, and then you cross here, you get 2xy times minus 4, you get minus 8xy. Then if you plus them, you get minus 5xy. So this is what we expected, yeah. So we are expected minus 5xy, so they are the same. So now we get the answer. The answer is this 2xy plus 1 and then times 3xy minus 4, yeah. So that is the answer, 2xy plus 1 times 3xy minus 4. So this is the factor of the expression. Okay, now is question number 4. Yeah, I think it's number 4. So review exercise 4, page 115, number 5a. So we have the expression, so we need to factorize the expression completely. So this expression is short but spatial, yeah. So I want you to remember the algebraic identity. So basically we have 3 algebraic identities. So the first one is here, yeah. So a plus b square is equal to a square plus 2ab plus b square. Yeah, I think you remember this. And then the second one is a minus b square is equal to a square minus 2ab plus b square. And for this question, you are going to use the third identity. So this identity is very common, yeah, to be appear in the question. So I hope you remember this identity. Okay, so a square minus b square is equal to bracket a plus b times inside the bracket a minus b. So this form is equal to the question here, the form in the questions, yeah. So the one here is perfect square, right? So the one here is like 1 square, is it the same thing? And 1 to 1 is like 11 square. So we can rewrite here, this is become 1 square minus 11 square x square, right? Almost the same. So this one 1 square minus 11x square. Okay, so you got the idea, the same form here. Now this is 1 is a and then 11x is b. So we can write like this, a plus b, it means 1 plus 11x, and then times a minus b, 1 minus 11x. So done. So this is the answer for these questions. Okay, now we are in the question number 5. Review exercise 4, page 115, number 6h. So we are going to factorize the expression here. So in this case, we are going to use group factorization, yeah. So I want you to remember you factorize based on the group like this. So you factorize the first part and then the second part, yeah. So the first part first. So I think you just need to pull out the common factor. So in the common factor here is 5x, yeah, because both of them can be divided by 5x. So I just want to write 5x and then bracket here y minus 2, right? Okay, good, that's good. And then the second part here, I think the common factor will be 6y, yeah, plus 6y. Okay, so I just want to make 6y and then bracket 12 minus 12y divided by 6y is minus 2, and then this one plus y. Okay, so here we can rearrange here. Minus 2 plus y become y minus 2, yeah? So we can rearrange 5x, okay, y minus 2 plus 6y, and then rearrange here y minus 2 also. Okay, yeah, we can see here this is y minus 2, y minus 2, and this one is 5x and 6y. So we can rearrange again here. The y minus 2 become 1, and then this one y minus 2 become 1, yeah? And then the next one will be 5x plus 6y. Okay, so done. This is the final answer. That's it. Okay, now we are in the questions number 6. So review exercise 4, page 115, number 9. Okay, the questions is if 2 bracket x minus y square equal to 116 and x times y is equal to 24, find the value of x square plus y square. Okay, in these questions we need to work on this equation, yeah? So we focus on this equation and then we try to find x squared plus y squared from this equation. So first thing, we need to move the 2 here to the right. So we can write something like this. X minus y squared is equal to 116 divided by 2, right? You move the 2 to the right, okay? And then after that, you know 116 divided by 2 is 58. So x minus y square is equal to 58. Now we try to expand x minus y square. So we will have using the identity, yeah, to make it faster. So you get x square minus 2xy plus y square is equal to this one, 58. Okay, so now we try to rearrange here. This is x square plus y square. Now we already have the x square plus y square. Now minus 2xy is equal to 58. Okay, so this is the thing that we are going to looking for actually, right? So this is the questions, x square plus y square. Okay, so now we have to deal with minus 2xy. So we have to change the value of xy. It's given here in the question, so xy is equal to 24. So we just need to change here to 24, xy to 24. So we can write here x square plus y square minus 2 times 24 equal to 58. Okay, 2 times 24 is 48. So this is minus 48, yeah? So x square plus y square minus 48 equal to 58. And then x square plus y square here is equal to, you move the minus 48 to the right, it's become plus, right? So 58 plus 48. So you can get x square plus y square is equal to 106. So this is the answer for x square plus y square. Okay. Okay, now we are in the 7th questions. So review exercise 5, page 141, number 3. Okay, so number 3, you are asked to solve the equations. So okay, I want to rewrite again the equation here. 2x squared minus 11x minus 21 equal to 0. Okay, just like the cross method, which we need to find this, the combination, yeah? So this one is like 2x and x, and here is like minus 7. Oh no, it's like minus 1 and 21 is possible. And then minus, what again? I think minus 3 and then 7, right? And it's also possible to be 1 and minus 21. Also possible to be 3 and minus 7. Okay, in this case, I think I'm going to use this part, yeah, and that part. Okay, so I want to try. This is 2x and x, representative of 2x squared, and then for minus 21 it will be, which one is which? Yeah, okay, I think I want to put this 3 and minus 7. Okay, let's try to use the cross method here. This is 3. Okay, so this is 3x and this is minus 14x. Okay, so when we try to multiply, cross multiply, we get 3x and minus 14x. When we sum them, when we add them, we get minus 11x. So minus 11x here is the same as the middle terms here, yeah, minus 11. So we got the answer now. The answer is this. This is for the factorization. We get 2x plus 3 times x minus 7, yeah. So here we can write 2x plus 3 times x minus 7 equal to 0. So when we have equal to 0, so we can find the value of x here. 2x plus 3 is equal to 0, or x minus 7 is equal to 0. So there are two possibilities, yeah. So when 2x plus 3 equal to 0, so 2x here is equal to minus 3. We move the 3 to the right, become minus 3, and then x here is equal to minus 3 over 2, yeah. So this one, or the x minus 7 equal to 0, so x here is equal to 7. So there are two possibilities, yeah. So either x equal to minus 3 over 2 or x equal to 7. Okay, so that is for the first part. We already got the answer. And now how about the second part? The second part is, hence solve the equation. The equation 2 bracket y plus 2 square minus 11 bracket y plus 2 minus 21. So when we look at this equation and then we compare it to the previous equation that we have solved, so we can see here, actually in the second equation is just changing x here, changing x to y plus 2, right? Because in the first equation we have 2x squared, the second equation we have 2 bracket y plus 2 square, and then minus 11x here is minus 11 y plus 2, and then minus 21, this is also minus 21. So actually we have the same pattern here. So basically the second question is just change the value of x into y plus 2. So to solve the equation in the second part, we can also simply change the x into y plus 2 here. So yeah, so here in the first equation we already get the answer, yeah, for 2 value of x. And then for answering the second part, we just need to change the value of x, change to here, what, change to y plus 2, yeah, change to y plus 2. So we have the possibility as well. So y plus 2 is equal to the same here, yeah, minus 3 over 2, or y plus 2 is equal to 7. So when y plus 2 equal to minus 3 over 2, so I move 2 to the right, y equal to minus 3 over 2 minus 2. So here minus 3 over 2, I change 2 become 4 out of 2, yeah, minus 4 over 2, so we get minus 7 over 2. So this is the value of y, or y equal to 7 minus 2, so y equal to 5. So there are two possibilities again now here. So the y equal to minus 7 over 2 or y equal to 5 for the second part, yeah. I think that's it. Okay, now we are in the 8 questions. So review exercise 5, page 141, number 7. Okay, so the questions is this. The length and the breadth of a rectangle are 2x plus 5 centimeter and 2x minus 1 centimeter. Yeah, this is rectangle. Okay, respectively. Okay, yeah. And the area of the rectangle is 3 times. Okay, so this is interesting. The area of rectangle is 3 times of the area of the square of side x plus 1. So we have rectangle and also square, and the area of rectangle is 3 times of the area of the square. Yeah, so we draw the rectangle and the square. Yeah, so the size of the rectangle is, the length is 2x plus 5 from here, and then the breadth or the width is 2x minus 1 here. Yeah, and then the square, the side is x plus 1. Okay, so the question is, form an equation in x and show that it reduced to x squared plus 2x minus 8 equal to 0. So how can we get the equations? Okay, so first we refer to the information here. The area of rectangle is 3 times of the area of the square. So here we can write the area of rectangle is equal to 3 times the area of square. Okay, so we can write the area of rectangle here, the formula. So length times width or breadth. So we have the length is 2x plus 5 times the breadth is 2x minus 1. Okay, and then 3 times the area of square. Area of square is side times side, so just x plus 1 times x plus 1, which means x plus 1 square. Yeah, okay, so now we try to expand here. This is 2x plus 5. 2x times 2x is 4x square. 2x times minus 1 is minus 2x, and then 5 times 2x is plus 10x, and then 5 times minus 1 is minus 5, equal to 3 times. So this one I just use the identity. Yeah, so it will be x squared, then plus 2x plus 1. Okay, so now I want to expand this, multiply by 3. Yeah, this one also I want to combine the minus 2 with 10, minus 2x with 10x, so 4x squared plus 8x. Yeah, because here we can combine, actually become plus 8x, and then minus 5 equal to, we multiplied by 3. Yeah, something inside the bracket, so 3x squared plus 6x plus 3. Okay, so now we try move all of the term on the left here, move it to the right. Yeah, okay, we try to move all the left term on the right term on the left. Okay, so change the color first. So 4x squared, and then this one 3x squared on the left become minus 3x squared, and then here still plus 8x at x, and then 6x on the right move to the left become minus 6x, and then I write again minus 5, and then 3 to the left become minus 3 is equal to, now on the right there is nothing, means equal to 0. Yeah, so now we combine here, so 4x squared minus 3x squared become x squared, and then 8x minus 6x become 2x, and then this is minus 5 minus 3 minus 8, and then this is equal to 0. So now we have the equation x squared plus 2x minus 8 equal to 0, just like the questions. Yeah, okay, so now it's a shown. Okay, now for the second part, we are going to solve the equations of x squared plus 2x minus 8 equal to 0. So we are going to solve that equation. So here the second part, so we write again x squared plus 2x minus 8 equal to 0, because the x squared coefficient here is only 1, so it will be easier. We directly don't use the cross method, is okay. So this one must be x and this is x. So we try to find two numbers. When we multiply these two numbers, we will get minus 8, okay? And if we try to we multiply, we get minus 8, and if we try to plus, we get plus 2. So what are those two number? Yeah, I think I'm thinking about 4 and minus 2. So 4 times minus 2 is minus 8. And then if we plus 4 plus minus 2, we get 2. So this is the answer, yeah? So we get plus 4 and then minus 2. Okay, so this is equal to 0. So we can say that x plus 4 x plus 4 is equal to 0, or x minus 2 is equal to 0. Okay, so x equal to minus 4 or x equal to 2. So of course this one will be rejected, because this one is negative, yeah? We deal with positive when we refer to the length. Okay, so the answer x is equal to 2. Okay, now for the last part here, find the perimeter of the rectangle. Okay, so the perimeter of rectangle, we just need to add, yeah? We already get the value of x, and we can find the length and the width. Okay, so for the third part, I want to write it here. I want to make the boundaries, yeah? Okay, so for the third part here, the length is, okay, and the length here is equal to, what is the expression? 2x plus 5, yeah? 2x plus 5. And then the width or breadth, okay, breadth, okay, sorry, wrong spelling. Okay, so the breadth is 2x minus 1. 2x minus 1. Okay, minus 1, yeah? So we just substitute the value of x equal to 2. So we got here 2 times 2 is 4 plus 5 is 9. And this one, 2 times 2 is 4 minus 1 is 3. So the perimeter of rectangle, okay, is equal to 2 times, okay, length plus breadth, yeah? So this one, 2 times 9 plus 3. So 9 plus 3 is 12. So 2 times 12 is 24. 24 what? Centimeter, yeah? Centimeter. So this is the answer. Okay. Okay, now we deal with the 9th questions. Review exercise 6, page 161, number 8. So here we are going to solve the equation. So this is about algebraic fraction, yeah? Okay, so for 8a first, I want to rewrite the question. So this is 12 over 5q plus 1 equal to 7 over q. So solving means that we are going to find the value of q. So here I want to move the 7 over q to the left, and then I want to move plus 1 here on the left to the right, so there will change, there will be sign changing, yeah. So here 12 over 5q, and then 7 over q here to move to the left become minus 7 over q, yeah, and then equal to 1 here to the right become minus 1. Okay, so now we have this equation, and the next step is make the denominator the same, yeah. So I can multiply q by 5 and then also multiply 7 by 5, yeah. So it will not change the fraction itself. Okay, when we multiply it, we get 12 over 5q, yeah. Okay, 12 over 5q, and then minus 7 times 5 is 35 over 5q equal to minus 1. And now the denominator already the same, yeah, so we can make it only 1. So 12 minus 35 is minus 23, so it will be minus 23 over 5q, and this is equal to minus 1. So now I can move 5q here on the denominator, on the bottom, yeah, division, move to the right side, become multiplication. So we can say minus 23 is equal to minus 1 times 5q. Okay, so we have minus 23 equal to minus 5q. So here if we want to find the q, so q here is equal to minus 23 divided by minus 5. So q here is equal to 23 over 5. So done. We got the value of q. Okay, now we deal with the b part here. I already rewrite the part b on the other on the white paper, yeah. So I just want to find the value of y in these questions. Okay, so here for the first step, I want to factorize 3y minus 9 here. So I want to rewrite, yeah, and then factorize something that can be factorized. So 5 over y minus 3, this already simplest, so I cannot factorize anything here. And then 7 divided by 3y minus 9. So I can pull out 3 here and then write the y minus 3. Okay, yeah. And then here plus 10 divided by, I also can pull out 2 here, bracket 3 minus y. Okay, here we can see the similarity, yeah, equal to 3, yeah. So the denominator must be the same, and we have y minus 3, 3 times y minus 3, and the last part is 2 times 3 minus y. This must be y minus 3, so we have to switch, yeah. So when we switch, we have the consequence, so it become negative here. So when we switch here 3 and y, yeah, so the positive here it will become negative. Okay, yeah, so we can write here 5 over y minus 3 minus 7 over 3 times y minus 3, same as that, y minus 3, and then this one become minus 10 over 2 times now become y minus 3. Okay, so this is equal to 3. Now we have y minus 3 on the denominator, yeah. Okay, so what next? The next step is we try to make denominator the same by multiply both of the side here by 6. Here 3 multiplied by 6, and all of here on the left side here all of them multiply by 6. Why 6? Because we can see here 3 and 2 can divide 6, yeah. Okay, 6 can be divided by 3 and 2. Why not 12? Why not 18? Yes, it's possible, but it's too big, yeah. So we try to find the least number, okay, the minimum number. Yeah, so we try to multiply both of the side by 6. So we got here 6 times 5 is 30. Okay, Alright, so wrong color. Want to use blue again. Okay, 30 divided by y minus 3, and then minus 6 times 7, but you can cancel 6 with 3, yeah? You get 2, so 7 times 2 is 14 over, so 3 already gone, yeah, already cancelled with 6, so over y minus 3, and then minus 6 times 10 is 60. 60 divided by 2 is 30, so 30 over y minus 3. Okay, yeah? So this one equal to 6 times 3 is 18. Okay, so this is our new equation. The denominator now the same. So we can minus here the numerator. 30 minus 14 minus 30. So it will be minus 14. Okay, minus 14 over y minus 3. This is equal to 18. So how can I get minus 14? Yeah, so one more. This one, the numerator, we try to plus them all. Yeah, 30 minus 14 minus 30. So 30 minus 30 is gone, yeah, 0. So the rest is just minus 14. Okay, so this is minus 14 over y minus 3 equal to 18. So I can move y here, y minus 3 to the right side, so it becomes multiplication. So minus 14 equal to 18 times y minus 3. Okay, so we try to expand here. Minus 14 equal to 18 y minus 18 times 3 is 54. Okay, now we move minus 54 to the left, become plus, yeah, so minus 14 plus 54 equal to 18y. So this one become what? 40, okay? 40 equal to 18y. So now we can get y is equal to, I move the 18 multiplication, move to the left, become division. So 40 divided by 18. So y we simplify to the simplest form, we get 20 over 9. So this is the value of y. Okay, we are now in the last questions. Review exercise 6, page 161, number 9. Okay, so this is the questions in an electrical circuit. When two resistors are connected in parallel, the effective resistance R, this is the symbol, yeah, this is one variable R, ohm, of the two resistor is given by the formula here. 1 over R is equal to 1 over R1 plus 1 over R2. So basically here we are facing three different variable, yeah. This is the variable 1, okay. This is variable 2, and this one is variable 3, okay, R2. So R1 and R2 are different, yeah, they are not the same, so be careful with that. So we're facing three different variable, okay, where R1 and R2 are the resistance of the individual resistor in ohm. Okay, so what we have to do with this equation, the first question, make R the subject of formula. So we are going to make this one, this R, as the subject of formula. Okay, I want to rewrite the equation. 1 over R is equal to 1 over R1 plus 1 over R2. Okay, so we are going to make R without the index, yeah. We want to make R alone, or the subject of formula. So how can we do that? The first here is, because this is a fraction, additional fraction, so we want to change the denominator, make denominator the same. Okay, so how can we make the same? So we can multiply R1 here with R2, and then this one also times R2. In the same case as this is times R1. Now denominator the same, yeah. This is times R1. Okay, Now we can have this equation. So R2 over R1 times R2 plus R1 over R1 times R2, right? Now the denominator already the same. This is 1 over R, so we can make it only one fraction. So R2 plus R1 divided by R1 times R2. Okay, this is 1 over R. Okay, yeah, so because this is 1 over R, we want to make R as the subject of formula. So I can flip this actually. So I can make the R on the top and 1 on the bottom, and then flip that, become R over 1, yeah. And then I also flip this one. Okay, flip this one, so I can write like this: R1 times R2, this is become numerator now, over R2 plus R1. Okay, so because R over 1 is R, yeah, so now you can just write R here. So you write again R1 times R2 divided by R2 plus R1. So now this is the formula. Okay, the R as the subject of formula. Okay, this is the answer. Okay, now so for the second part, hence find the effective resistance. So what is the effective resistance? This is the area, the effective resistance of the two resistors if R1 here is equal to 2 and R2 is equal to 3. So we are going to find the value of R when R1 is equal to 2 and R2 equal to 3. So this is easy. For the second part, so when R1 here is equal to 2, yeah, and R2 is equal to 3, so we are going to find the value of R. What is R? Yeah, like that. So first we write the equation that we already got from the first part. So here R here is equal to R1 times R2 divided by R2 plus R1. And now we just need to substitute the R1 and R2 to the formula, to the equation. So we can here we find R1 is 2 times 3 divided by 2 plus 3. Okay, this is R. So R equal to 6 over 5. So what is 6 over 5 actually? So this is equal to 1.2. So the R here is 1.2 ohm, yeah. So this is the symbol. Okay, so that's all. Thank you very much.